All right, so taking a look at the lab for this week. So for this week's lab, what we're dealing with specifically is going to be die rolls. So the purpose of the lab this week is to implement what is known as a Monte Carlo simulation, which basically just means it's kind of like a brute force simulation of something where instead of doing the actual math to figure out, in this case, the probability of rolling a particular side of a die, you instead just simulate rolling a die over and over again. And then based on the results that you get from that, you can essentially determine what those probabilities actually are. So obviously with something like die rolls, doing this is kind of unnecessary because most people can just figure out that the probability is 1/6 for any particular side of a die. Where this becomes a bit more interesting is with much more complicated systems. Maybe something like if you wanted to check the math for uh, drawing cards out of a deck of playing cards, that might be a good example of it. But for this one, we'll go ahead and do something really simple since obviously trying to do playing cards might be a bit too much. So the concepts that we're going to cover with this lab will include things like for loops. So we're going to be relying on a for loop to interpret or kind of iterate over the number of simulations that we're going to do. As we'll see in a moment, for this one, we're going to do a few thousand of them. We're also going to deal with file input. So in this case, we're going to be writing to a file with the results of our simulation. So that's going to include things like the counts, the number of times we rolled each one of the different sides. And we're also going to take a look at the percentages related to that. And then the last thing is going to be randomness, since obviously rolling a die is meant to be treated as a random event. So we want to make sure that we capture that properly. So going through the task for this week's lab, you're going to go ahead and create a project called die rolls and then your first and last name, or lab 7 and your first and last name. You also want to make sure that you're including comments summarizing the program. And then an additional point that I make right here is that you only need to submit the Java file for this assignment. So at the end of this, when you've ran it, the output is going to go to a text file. You do not need to give me that text file, since as soon as I run your program, I'll also end up generating a similar looking text file. So you don't have to worry about including that with your submission. So then another thing that I included with the task here is just a brief description of what a Monte Carlo simulation is. So just goes back to what I mentioned just a moment ago. But essentially it refers to this process of repeatedly performing an action and then saving the outcomes or results of that action. And then we usually use this to prove mathematical models or to be able to observe the probability of random events. So then going through each of the steps for our task. For step 1, you'll go ahead and start setting this up to be able to write the results of a Monte Carlo simulation of die rolls to a file. So this means you're going to need to import the classes for file input as well as the random class. Additionally, you'll need to remember to include a throws clause in the main method header. As soon as you try to write any lines of code that are related to the print writer that you're going to make for this, you should expect to see an error. And if you check the error, it's going to tell you that you're, something like not handling the exception or not catching the exception. That's going to be a tip to you to let you know that you might be missing this throws clause in your main method header. So another little small detail to make sure that you remember there. For step 2, you'll go ahead and declare 6 int variables that will hold the counts for each result of the die rolls. So this includes things like rolling a 1, rolling a 2, etc. So you need 6 of those for each face or each side of the die. You'll then go ahead and declare and construct an object of the printwriter class that will write to a file called die rolls, and then with the extension .txt. And then you'll also declare and construct an object of the random class. For step 3, this is going to also be broken up into a few sub-steps, since this is the part where you're going to actually create your for loop. So you're going to write a for loop that will repeatedly generate a random number. And in this case, we're going to go ahead and do this 10,000 times. I think that that's more than enough to be able to see that probability of about 1/6 for each side of the die. And so then for each iteration of that for loop, there are going to be two primary tasks that you need to complete. The first is that you want to go ahead and generate your random number from 1 to 6. This essentially is going to represent the behavior of rolling a die. And you also want to keep in mind the method of the random class necessary to accomplish this and the expected outputs. Another thing that I'll note about this that's not directly included in these directions is that when you get this random number, you might want to store this into another int variable so that then when you deal with step B right here, you're going to have to check to see what that number actually is so you can determine which count to increment. So it might be easier to do that if you store the results into a variable right here. So then in step B, depending on the random number generated, you're going to go ahead and increment the corresponding count. For example, if a 1 is randomly generated, then you want to increment the count corresponding to 1s. And then if a 2 is rolled, increment the count corresponding to 2s, and then so on and so forth. Okay. So then once you've completed everything for your for loop, after you've gotten all of your results, or in this case, I say after performing the 10,000 rolls, you will go ahead and print the counts and then the percentage of counts out of the total rolls to your text file. That's going to be that die_rolls.txt. You can use the following formula to calculate each of those percentages. So each percentage is going to be equal to whatever count you got for each of the 6 different ones you're going to be dealing with, divided by the total, which in this case is referring to the 10,000 total rolls that you're dealing with. And then because you need to treat this as a percentage, you'll go ahead and multiply it by 100. And then for the percentages, I also want you to go ahead and round them to 2 decimal places in the formatting. And you can refer to the sample output right here to see the expected output to the file. And then finally, in the last step, so after you've completed everything for this lab and you've written all of these essentially 6 statements here to the file, the last thing you want to make sure to do is actually close the file. And as a warning about this one, if you forget to close the file, because the only thing you're dealing with here is writing to it, what's going to end up happening is your file is going to be empty. So if you don't see anything writing to the file when you're finished with the program, it's because you forgot to close it at the very end. Okay, so then taking a quick look at this output, we can see right here, for each one of the 6 different counts that you're going to be keeping for your 1s, 2s, 3s, 4s, 5s, and 6s, you're going to go ahead and print out the number of times you rolled that particular side. So you can see each one of those 6 counts right here. And I'll go ahead and mention now that these 6 counts will not be exactly the same every time. That's to be expected because, again, it's completely random. But what you should be seeing is something that's pretty close to about 16% for each one of them. So you can kind of see right here with the numbers, you get things anywhere from a little over 16% all the way up to maybe a little over 17%. These are pretty normal amounts that you should expect. If you're seeing anything that is drastically different from this, then you might have some kind of error in the way that you set up the for loop up here. Okay, so then going through the criteria, you're going to have your comments describing the program. These again will be worth 5 points. Correctly importing the necessary classes and then adding the throws clause and declaring the variables necessary for this program. All of that's going to be worth 15 points. So that's corresponding to, I believe, the first 2 steps. Yes, that would be for steps 1 and 2. Correctly writing the for loop to iterate 10,000 times is going to be worth 10 points. So that's the very beginning of step 3. And then correctly implementing the logic in the for loop to generate a random number and then increment the correct count is going to be worth 35 points. That's referring to the actual 2 parts of step 3, so parts A and B for it. And then calculating the percentages and printing all of the results to the text file is going to be worth another 35 points. And that's referring to step 4. Okay, so that's going to cover everything for the directions for this week's lab. In a moment, I'll switch over to NetBeans and actually run it and then show you the results from having ran the program. But before I switch over to do that, does anybody have any questions of the lab so far? Okay, so if there's no questions right now, go ahead and switch over to that. Okay, so right here, I've got my file, the Java file for this already written. So what I can go ahead and do is just run this. And so when I run this program, we're not going to see anything on the console because the entire output for this is being written to a file. If you're doing this through NetBeans, there should already be a mention of this from the video that talks about file input and output. But where you're going to expect to see the actual results is if you go to Files right here and select that, you can actually see the folder for your project. Just go ahead and open that up. And then right here, you can see your diroles.txt. I'm just going to go ahead and open that up. And I'm going to make this a little bit larger now. And so then we can actually see the results right here. So you can see for me, I'm getting anything from 16.10% at the lowest up to about 17.34% at the highest. This is a pretty typical range that you might expect for something like this. Okay, so that'll cover the demo as well. At this point, it might be better to start working with NetBeans. If you want to do it through REPL, that's fine too. I will say that if you do it through REPL, I've not tested file input and output on REPL before, so I don't know precisely off the top of my head where the text file is stored. I'm pretty sure they have a project directory, so it's probably just right there somewhere. But I don't immediately know where it is. But other than that, yeah, if you want to use REPL, then you could certainly do that. Okay. Were there any other questions about the lab? Okay. The other thing that I want to mention just real quick, and I'll include this with the recording, is the first exam for you guys has been graded. So if you take a look on Blackboard, you can see that. So you can see how you did on it. And if you missed any of the questions, you can see the feedback that I gave. For pretty much all of them, I was either on the fill in the blank, I specified the exact parts that you missed. For pretty much any other question, I just gave you like the entire answer. So basically from there, you can kind of estimate about how close your answer was to the correct answer based on however many points you lost on that. The other thing to clarify, just in case it's not very clear with the way that I set up the feedback for it, the bonus question out of your short answer questions, you'll be able to see which one was treated as the bonus because I put that in all caps and then I put the score out of 10 points. But then when you actually look at the way that Blackboard lists it, it'll say that it's out of 15 points. I just want to clarify that that difference that you're seeing there is just because of the fact that Blackboard doesn't allow for variable grading where you can like change the number of points that something is worth based on the context of the question. So I'm just trying to do the best that I can with the feedback to clarify what's going on there. Okay. And also, of course, if you have any questions about anything that you might have missed on the exam or how many points you got, you can certainly double check with me about that as well.